Today we're going to be talking about long division and remainder factor theorems. And when we're going to talk about long division, we're going to go back to grade school and we're actually going to look at long division. So that what we did with numbers, we can now do with polynomials. And I have picked the problem 4,711 divided by 23. So 23 is my divisor, and it is dividing into the dividend of 4711. And our job is to find the quotient. So we always took the divisor and put it on the outside, and we put the dividend on the inside. And this is what's amazing to me, is that a lot of people found division hard, and I believe it's because you never thought about looking at it as looking at this first digit. And I would always teach my kids that 23, when I look at the 2, that 23 rounds to a 20. So it's like asking, how many times does the 2 go into the 4? So most people would say twice. So then you came over here to the side and you wrote 23, the entire dividend, times 2 to see if that worked. And when you multiplied, you had 46. And that did work. So then you wrote 2 up on top, and you wrote 46 down here. Then you subtracted. But you not only subtracted the tens place, you also subtracted the ones place. When you subtract the tens place, you got 0. When you subtract the ones place, you got 1. And then you brought down your next term. And then you would say, go back to the 2, and 20 goes into 11 how many times? And you would say 0. So then you would bring down the other 1. And you would say 20 goes into 111 how many times? You still always went back to this first digit. And people would say 5. So you'd come over to the side and you'd take the entire dividend times 5. And you got 115. He said, that's too big, so then I know it must be 4. And then you'd come over to the side and you would actually take 23 times 4. The whole dividend times your factor. And when you multiplied, you got 92. And then you would subtract the tens digit and the ones digit. And you would have 19. And at one point, you would write remainder 19. But then as you got more sophisticated, you should have learned that it meant and 19/23. And that is how you learn to long divide. When you use polynomials, you use that exact same process. Every place value needs to be accounted for. Just like here, I had to account for the units, the tens, the hundreds, and the thousands place. When I have polynomials, I must account for every polynomial place. So, here, y to the 4th plus 2y squared minus y plus 5 divided by y squared minus y plus 1. My dividend is y squared minus y plus 1. And I'm dividing that into my divisor of y to the 4th plus 2y squared minus y plus 5. Has every place value been accounted for? Y to the 4th, y cubes, whoops, I have to insert my y cubes. I had 0 y cubes. Then my y squareds, then my y to the first, and lastly, my y to the zeros. Now I have every place accounted for and can do the exact same process as I did up here. Up here I looked at the first digit. So in my polynomial, I'm going to look at the first term, which is y squared. How many times does y squared go into y to the fourth? Y squared times. So then I take my y squared times my entire dividend, y squared minus y plus 1. And I get y to the fourth minus y cubed plus y squared. And then I write that down, y to the fourth minus y cubed plus y squared. And I draw my bar. And I must subtract this entire place. So when I am subtracting the y to the fourth and the negative y cubed. So subtract means add the opposite. So that becomes a positive. Y to the fourth minus. So when I am subtracting, then adding, then this changes to a subtracting. So y to the fourth minus y to the fourth is 0. 0y cubed plus 1y cubed is y cubed. 2y squared minus 1y squared is a positive y squared. And then I bring down my next term, negative y. And again, I go back to the beginning. Y squared goes into y cubed. And I would say positive y times. So then I come over here and take my y times my entire dividend. Y squared minus y plus 1. And I get y cubed minus y squared plus y. And I write all that down. Y cubed minus y squared plus y. And then I must subtract all of this. So subtract, add, subtract. Y cubed minus y cubed is 0. Y squared plus y squared is 2y squared. Negative y minus y is a negative 2y. And I bring down my 5 plus 5. Then again, I go back to my y squared, goes into my 2y squared. How many times? Positive 2 times. So I come over here and I take 2 times my whole dividend, y squared minus y plus 1. And I get 2y squared minus 2y plus 2. And I write 2y squared minus 2y plus 2. And then I must subtract every one. 2y squared minus 2y squared is 0. Negative 2y plus 2y is 0. 5 minus 2 is 3. So it is and 3. And in math means plus 3 over my divisor of y squared minus y plus 1. And that is my result. Long division of polynomials is exactly the same as long division of numbers. And it takes practice. Now, if you notice here, My divisor was y squared minus y plus 1. It was a trinomial, 3 terms. When we have 3 or more terms, we have no choice but long division. If we have a binomial with 2 terms, then we have choices. We can do what is called synthetic division. It is the exact same process as synthetic substitution. The only difference is, in synthetic substitution, you were given a value to put in your divisor box. Now, your divisor box is going to hold the root. The divisor must be in the x minus h form. And then x minus h equals 0. Solve for x, x equals h. H is my root. So you're always going to take your factor and make it your root and put that in the divisor box. Here's an example. If I look at x cubed plus 2x squared minus 6x minus 5, all divided by x minus 2. This is a binomial because there are only 2 terms. I can then use synthetic division. So, by synthetic division, this is in the x minus form. So, x minus 2 equals 0. So, I add 2. And my root is 2. 2 is what goes in the divisor box. Then I just take the quotient, the coefficients of all of my dividend. I have 1x cubed. I have positive 2x squared, negative 6x, and negative 5. I should check that all places were taken care of. 3, 2, 1, 0. So I am good. Then I bring down my 1. 2 times 1 is 2. Add 4. 4 times 2 is 8. Add 2. 2 times 2 is 4. Add negative 1. This is my remainder. This becomes my remainder, x to the 0, x to the 1, x squared. So my polynomial is 1x squared plus 4x plus 2 minus 1 over x minus 2, my dividend. We're going to have you try one. It says divide x cubed minus x squared minus 2x plus 8 by each binomial. So the first one we're going to do is divide by x minus 1. So my root would be x equals 1. So 1 goes in my divisor box. Then I must take care of each term. Since it's cubic, I need 4 terms. 1, 2, 3, 4. So I write those coefficients down. 1x cubed minus 1x squared minus 2x plus 8. And I draw my line, bring down my first term, and I have 1. 1 times 1 is 1. Add 0. 0 times 1 is 0. Add negative 2. Negative 2 times 1 is negative 2. Add 6. Remainder, x to the 0, x to the first, x squared. So my result of dividing x minus 1 into x cubed minus x squared minus 2x plus 8 is 1x squared plus 0, so I don't write that, minus 2x to the 0, which is minus 2, plus 6 over my divisor, which was the factor x minus 1. That is my resulting polynomial. Let's now try it with b, x plus 2. First find your root. Subtract 2. X equals negative 2. So negative 2 goes in my divisor box. Same polynomial, so the coefficients are 1, negative 2, 8. Bring down my 1. 1. 1 times negative 2, negative 2. Add, negative 3. Negative 3 times negative 2, 6. Add, 4. 4 times negative 2, negative 8. Add, 0. That's my remainder. X to the 0. X to the first. X squared. So my resulting polynomial is 1x squared minus 3x plus 4x to the 0, which is just plus 4, plus no remainder. So synthetic division comes in quite helpful when you're dividing by binomials, but if you have anything other than a binomial, you have no choice but long division. Now we're going to take this just one step further. For any polynomial to have factors, the remainder must be 0. Therefore, x minus k is a factor if f of k is 0. Remember before, we would have done x minus k equals 0. Add k. So x equals k. That was my root. So when I substitute in k and get a remainder, a root of 0, I actually had a true factor. So knowing that, it can help us find the zeros of a function, because that meant we set the function equal to 0, which is actually what we did. So let's try this one. Let's factor f of x equals 3x cubed plus 13x squared plus 2x minus 8. If I know that f of negative 4 equals 0, that means when I evaluate the root of negative 4, I get a remainder of 0. This is my root. This is my remainder. And if my remainder is 0, this root can be changed to a factor by writing it in the x minus 4. So I already know one of my factors is x minus negative 4, which would be x plus 4. That is my factor that gave me this root. So if I use synthetic division, I should be able to find the other factors. So I put the root in the divisor box, negative 4. Then I make sure I have every place. Cubed, squared, first 0. So 3, 13, 2, negative 8. Bring down my 3. 3 times negative 4, negative 12. Add 1. 1 times negative 4, negative 4. Add negative 2. Negative 2 times negative 4, 8. Add 0. I better have had 0 as a remainder because that's what I was told in the beginning. So I already have this factor, x plus 4, times What factor remains? Remainder, x to the 0, x to the first, x squared, times 3x squared plus 1x minus 2 should equal 0. Can you then factor this further? Let's try it. Parenthesis, parenthesis. How would you factor 3x squared? 3x and x. What are the factors of 2? 2 and 1. Inside 2x, outside 3x. I need their difference to be 1. I have that. I need it to be positive 1, so that needs to be positive. First is negative, second is positive. So I now have a completely factored form by using synthetic division. This question says, one of my zeros is negative 5. Find the other zeros. That means once I've found all the factors, I can set each of them equal to 0. So again, if one of my zeros was negative 5, that came from the factor x minus a negative 5, which is x plus 5. That is one of my factors. So I can take this root of negative 5 and put it in the divisor box. And then I can take each coefficient and put them down. 1, positive 6, positive 3, negative 10, cube, square, 1, 0, and I'm good. Bring down my 1. 1 times negative 5, negative 5. 6 times plus negative 5, 1. 1 times negative 5, negative 5. 3 plus negative 5 is negative 2. Negative 2 times negative 5, positive 10. 0 remainder. And I should have gotten that because negative 5 was a root, was a 0. Remainder, x to the 0, x to the 1, x squared. So I have the first factor, x plus 5, times 1x squared plus 1x minus 2 equals 0. Can I factor this further? X squared would be x and x, the factors of 2 that differ by 1. 2 and 1, a positive 1. Since it asked for the zeros, I must now solve this. So x plus 5 equals 0. Subtract 5. X equals negative 5. 1 root, which they gave me. X plus 2 equals 0. Subtract 2. X equals negative 2. A second root. X minus 1 equals 0. Add 1. X equals 1. A third root. 1, 2, 3 roots. Power of 3 should have 3 roots, just like power of 2 had 2. And after I found the factors, I can find the zeros or the roots. This is a lot for you to practice, but give it a shot, and we'll go back through it on Monday if you have questions. Page 356, 15 to 54, in multiples of 3.